we're going to be able to find out exactly how much money is going to be in her account too. Okay? So, determining the future value of these investments, we are going to, we have to calculate a couple things here first, right? So, here's the formulas. There is the formula for compound interest. The annual interest rate is 9%, decimal form 0.09. The monthly interest rate is, now remember, because it's compounded monthly, so it's the decimal form of the percent divided by 12 monthly, 12 months in a year. And so this is your number here. That is the interest rate per month. That's I. Okay? So that's your big thing. It's monthly, so you take the annual rate divided by 12. That's what you get. So this is the I that you're going to use in your formula. The number of compounding periods. Okay, for the mom, she has 15 years at 12 times per year. So she has 180. That's for N for the mom. So where's the mom here? Here's the mom. See, 180 in for N. This 0.0075 is the interest rate for both of these. But look at the big difference here. The number of compounding periods for the daughter's investment is, okay, 65 minus 18, what's that? 47, okay, times 12 is 564. Look at the difference, okay, the number of compounding periods. And so in her formula, that's what she puts there. Now look at this, the difference between the two. Obviously, the daughter, it's going to be in there quite a bit longer, but look at this. 5,000 versus 101,000. That's huge, okay? The daughter's future value is over $95,000 greater, okay? Now, I know there's not a lot of high school students that are able to put $1,500 away until they're 65. That's a lot of foresight. That's a lot of money. But look at, if you get some kind of, let's say you get some money given to you, you have some kind of inheritance or something. I don't know, it happens. And let's say you get $10,000 given to you. Boy, it's going to be really hard not to buy a new car, a new phone, and a new pair of shoes or a new muscle shirt and spend it all. But let's figure out how much that would be worth. Let's say you're 18. Let's say you get $10,000. Okay, 10,000. I want you all to do this. Okay, and you're gonna leave it in there till you're like really old. Like how old? How old's really old? How long do you think you could leave it in the bank for without touching it? What? Till you're age 20. Wow. 10 years. Okay, thank you. It's very enthusiastic. Thank you. 10 years. Okay, so let's say this was the same situation for you. Same percent, compounded monthly. What would $10,000 turn into in 10 years from now? Okay, go ahead and take a second to calculate that. So this is what you should get right here. Principal 10,000, interest rate per compounding period plus 1 is this value right here. 10 years times 12 months is 120. So your $10,000 turns into $24,513. Okay, pretty good deal. Next thing I want to talk to you about is this rule of 72. So this is on page 27. This is a good estimating tool. If you want to find out how long it would take for you to double your money, if you have money put away and it is accumulating compound interest, you can roughly guess how long it will take to double your money. That's what this rule of 72 is. So once again here, it is a simple formula for estimating the doubling time of an investment. And how is it done? 72 is divided by the annual interest rate. And that's as a percent, not the decimal, but the percent. And that estimates the doubling time of an investment in years. Okay? So an example would be, you have any amount of money. So let's say we have $10,000. That was that $10,000 that we in our previous question. $10,000, and we have an interest rate, what was it, 9, annual interest rate? So 72 divided by 9, what's that? That's 8, right? So we're saying that money should double in 8 years, approximately. And if we looked at this example, we had $10,000, and then in 10 years, it became 24,500, right? Somewhere around there. So where would it double? Well, it's going to double sometime before 10 years. And according to our estimation, it's about 8 years. So in about 8 years, it should be about $20,000 bucks. So that's an estimate. Let's just double check that. Let's verify to see if that's anywhere near. And of course, we can do that by using our formula that we just learned. So if we have 10,000, no, we have 10,000. We're going to find out what the future value is, right? And we're going to check after 8 years. So it was a 1.75, 0.0075. How many compounding periods after 8 years? 8 times 12, 96. Okay, I got that right, yeah. Okay, so let's see if we're close with our estimate of 8 years for the money to double. This should be somewhere around 20,000 bucks, so let's just see. So if we check it out in our calculator, we have 20,489. So as far as an estimate goes, that's a pretty good estimate. 10,000 turned into $20,400. Okay, so approximately $20,400. So it's a good guess. So the rule of 72 is a pretty good guess if you just want to like plan, especially if the bank is giving you several different options of accounts for different compound, rates or whatever. How much money do you need and when? That might help you make some decisions.